So this problem is very similar to where we have the exponents that are fractions. So we're going to use our calculus-related substitution technique that we learned. So I'm going to let the variable u stand for y to the negative 1. It's always going to be this kind of middle term. So if that were a fraction 1/5, it would be u equals y to the 1/5. So same sort of logic that you've been using. So now when I resubstitute, notice that y to the negative 1 squared is going to give me y to the negative 2, because remember you multiply your exponents. So on the outside I'm going to have u squared minus 2u plus 3 equals 0. This does not factor, so I'm left with the quadratic formula. So if I use a quadratic formula, I have opposite of b, so 2 plus or minus b squared minus 4ac all over 2a. That simplifies into 2 plus or minus root negative 8 over 2. And I can simplify that further to be 2 plus or minus 2I root 2 over 2. And remember, as long as all three of these are divisible by the same number, it's valid to do that. So now we have 1 plus or minus I root 2. So it's very important to notice that we solved for the variable u. So now I'm going to go back in and resubstitute. So this u and this u right here. So I can simply say y to the negative 1 equals 1 plus or minus I root 2. Okay, so now our goal is to get y by itself. So what do I have to do to y to the negative 1 in order to make it y to the first? Isn't that my goal, to get y to the first? That's just y. So what can I do to this negative 1? Well, I can multiply it, or I can raise it to the negative 1 power. And then I can raise this one to the negative 1, because negative 1 times negative 1 is positive 1. And y to the first is simply y. So on this side, I have 1 plus or minus I root 2 to the negative 1 power. So if you recall your rules with exponents, if I have, let's say, 5 to the negative 1 power, remember I told you make that into a fraction and then move it down and make it positive. So this just moves down. Oops, sorry, lost my paper there. So if I have 5 to the negative 1, that becomes 1 over 5 to the first power, or just 1 over 5. So if you remember that rule, we're just going to apply the same rule over here. So I'm going to make this y is going to be 1 over 1 plus or minus I root 2. Okay, so we know that we can't leave this radical or imaginary numbers both. We got a double whammy there in the denominator. So we have to multiply by the conjugate. And my conjugate is going to be 1. Now, if it's a plus, then the conjugate is going to be negative, and if it's minus, then the conjugate is going to be positive. So right now I'm just going to leave plus or minus, and you'll see how it really doesn't matter in the end. And then 1 plus or minus I root 2. So in the top, our numerator is going to be 1 plus or minus I root 2. So in the bottom, let's think about this. Remember, the conjugate always has to be the opposite sign. So since I have two factors here, does it really matter which one is positive and which one is negative, as long as one is positive and one is negative? So it really doesn't matter. So I'm just going to pretend that this one is minus and then this one would be plus. But it's going to be the same if I had reversed it. So it really doesn't matter which order I do them in. So remember, when we multiply by the conjugate, it's the first two terms, so 1 times 1 is 1, and the second two terms, so minus I squared root 4. So be careful. I times I is I squared. Root 2 times root 2 is square root of 4. So I can simplify a couple of these things. Oops. Sorry. So I can simplify a couple of these things. This becomes 2, and this becomes negative 1. So let's put this together. I have 1 minus negative 2. And doesn't that just become positive 3? So this becomes positive 3. So that's my denominator. My denominator is positive 3. And on the top, I have 1 plus or minus I root 2. And that is my final answer. I know in the back of the book, your book separates this into 1/3 plus or minus I root 2 over 3, but actually this is a more proper form to keep it over just one single denominator. So that's a little neater answer than the back of the book, actually.